Hello everyone, this is Raman sir making maths simple for you. Welcome to my YouTube channel called Maths Academy. Today's topic is mathematical induction. Dear students, in the previous 4 videos, already we have solved some of the most important questions related to mathematical induction. If you have not watched, please watch it. Dear students, today in this video, we are going to continue the next question of mathematical induction. So here we are going to prove a question involving natural number by using the principle of mathematical induction. So dear students, the question is applying principle of mathematical induction, prove that 3n is greater than or equal to 2n plus 1. So dear students, in this problem we are given a statement related to inequality, and by using the principle of mathematical induction we have to prove it, where n is the natural number. So dear students, in order to prove any given statement by using the principle of mathematical induction, at first we have to prove that the given statement is true for n equals 1. That means if we take the value of n, which is also known as the number of terms, if we put the value of n equals 1, then we prove that it is true for n equals 1. Then secondly, we prove that the given statement is true for n equals k plus 1 whenever it is true for n equals k. So dear students, mainly there are 3 steps. Let's recall it once again. At first, we have to prove that the given statement is true by taking the value of n equals 1. Then we assume that the given statement is true for n equals k. By assuming that the given statement is true for n equals k, we prove that the given statement is true for n equals k plus 1. And lastly, we conclude that the given statement is true for all the natural numbers n belongs to n. So dear students, this is the principle of mathematical induction, which we have already discussed in the first video of this section. So dear students, so let's prove this. We have to prove that 3n is greater than or equal to 2n plus 1. At first we suppose the given statement as Pn. So let Pn be the given statement. Let Pn be the given statement. Dear students, now we can write it as Pn such that 3n is greater than or equal to 2n plus 1. So this is our statement. We have proved that 3n is greater than or equal to 2n plus 1. So according to the principle of mathematical induction, at first we prove that it is true for n equals 1. That means if we take the value of n 1, then the expression of LHS and expression of RHS must hold greater than or equal to condition. Dear students, now we have to prove that this statement is true for n equals to 1. When n is equal to 1, when n equals to 1, 3n must be greater than or equal to 2n plus 1. So let's put the value and let's observe it. So let's put the value of n1. So if we put the value of n1, then we get 3 times 1, which is equal to 2 times 1 plus 1. So dear students, now 3 times 1, that means we get 3 equals 2 1s are 2, 2 plus 1 we get equals 3. So dear students, we see that 3 is equal to 3. That means if we take the value of n equals to 1 and substitute in the given statement, then we see that we have got the right result. That means if we put value of n equals 1, then we have proved that 3n is greater than or equal to 2n plus 1. So dear students, now the second step of mathematical induction is we have to assume that this statement is true for n equals k. So let's assume that the given statement is true for n equals k. Let us assume that Pn is Let us assume that the given statement is true for n equals k. So let's put the value of n equals k in the given statement. So dear students, if we put the value of n k, that means if we replace n with k, then the statement will be pk such that 3k is greater than or equal to 2k plus 1. So simply we have put the value of n k in the given statement, then our statement will become pk such that 3k is greater than or equal to 2k plus 1. So dear students, according to the basic principle of counting, we assume that, dear students, according to the principle of mathematical induction, we assume that the given statement is true for n equals to k. Then we show that this statement is true for n equals k plus 1. So let's suppose this statement as I. Now we show that Pn is true for Pn, that means our given statement is true for n equals k plus 1 when it is true for n equals k. That means when pk is true. When pk is true. So dear students, let's now substitute the value of n k plus 1 in our given statement. So dear students, now we are going to substitute the value of n k plus 1 in the given statement. So our statement is, dear students, our statement is Pn such that 3n is greater than or equal to 2n plus 1. So now we are going to put the value of nk plus 1 to show that pk plus 1 is true. So dear students, our statement is 3n greater than or equals to 2n plus 1, which is the given statement. Now if we substitute, if we put the value of nk plus 1, then we get 3 times k plus 1, 3 times k plus 1 greater than or equal to 2 times k plus 1 plus 1. So dear students, simply we have substitute. Simply we have put the value of n k plus 1. Then our statement becomes pk plus 1 such that 3 times putting the value of n k plus 1, then we get greater than or equal to 2 times k plus 1 plus 1. So dear students, now we are going to prove that this statement, that means the given statement is true for n equals k plus 1 whenever it is true for n equals k. So dear students, in order to prove that the given statement is true for n equals to k plus 1, already we have assumed that the statement is true for n equals to k. So let's take it, let's use it now. So dear students, by 1 we have 3k greater than or equal to 2k plus 1, and by solving this, now we are going to show that it is true for n equals to k plus 1. That means by solving this result, we have to find that 3 times k plus 1 is greater than or equal to 2 times k plus 1 plus 1. So dear students, here we have to use some manipulation, that means some tricks and techniques. So the LHS expression will make equal to 3 times k plus 1. So dear students, the LHS expression, which is 3k, we have to change in the form of 3 times of k plus 1. So already we have got 3, so 3 as it is. Now this k will change in the form of k plus 1. So this k we have to change in the form of k plus 1. That means we have to add plus 1, and in order to balance we have to put minus 1, and keeping the RHS expression, the right hand side expression as it is. So dear students, this implies 3 times k plus 1 minus 3 1s are 3. Simply we need the expression 3 times k plus 1. So already we have got now the expression 3 times k plus 1, and 3 1s are 3. So dear students, now minus 3 will move to the right hand side. Then we get 3 times k plus 1 greater than or equal to 2k plus 1. So if we move minus 3 to the right hand side, then we get plus 3. So dear students, the expression of left hand side, that is 3 times k plus 1, we have already got. So now we'll keep it as it is. Then we make the right hand side expression equals to 2 times k plus 1 plus 1. That means now we have to simply solve the right hand side expression, which is 2k plus 1 plus 3. So this expression we are going to change in the form of 2 times k plus 1 plus 1. So dear students, now keeping the left hand side expression as it is, 2 times k plus 1 plus 3. So dear students, now we need 2 times k plus 1 plus 1. So this expression we have to change now in the form of 2 times k plus 1 plus 1. So here also we have to use a little bit trick. So to make 2 times k plus 1, simply we copy this expression over here, 2 times k plus 1. We need 2 times k plus 1 plus 1. So dear students, simply we copy the expression 2 times k plus 1 plus 1, and then we'll balance all these terms with the terms 2k plus 1 plus 3. So let's balance it. 2k already we have got, 2 1s are 2, and again plus 1, 2 1s are 2 plus 1, that means 3. So already 3 is also balanced. So extra term, the remaining extra term is 1. The remaining extra term is 1. So dear students, now we can write this expression greater than or equal to 2k plus 1, 2k plus 1 plus 1. So dear students, at last we copy the expression 2 times k plus 1 plus 1. Now we see that the expression 2 times k plus 1, 2 times k plus 1 plus 1, we can say that 2 times k plus 1 plus 1 plus 1 is greater than or equal to 2k, 2 times k plus 1 plus 1. So dear students, the expression 2 times k plus 1 plus 1, which already we have got, and again we have got plus 1 more. That means this whole expression we can say greater than or equal to parts of its expression. So dear students, now easily we have got 3 times, this implies 3 times k plus 1, 3 times k plus 1 we have got greater than or equal to 2k plus 1 plus 1. So dear students, this type of problem is very easy. Simply we have to do some manipulations. So dear students, I hope that you have understood how to solve the problems, this type of problem, by using the principle of mathematical induction. At first we have to show that the given statement is true for n equals to 1. Then by assuming that the given statement is true for n equals to k, we show that the given statement is true for n equals k plus 1. So at last we have to write on the, dear students, at last we have to write on the conclusion. According to the principle of mathematical induction, if a statement is true for n equals to 1, it is true for n equals to k plus 1. Whenever it is true for n equals to k, then we can say that so we have to write on the conclusion pk plus 1 is true. It shows that pk plus 1 is true. Now the final conclusion is, hence by the principle of mathematical induction, Pn is true for all n belongs to n. That means now we can say that the given statement is true for all the natural numbers n belongs to n. So this is according to the principle of mathematical induction. So dear students, I hope that you have understood the solution of this problem. Next time we'll meet with the new content. Till then, bye. Have a nice day. Thank you.